Good morning students. The previous class we have learned some of the basics of the Hyperbola chapter. So before watching this video you are all requested to watch them and continue watching this. So today we will be learning about the director circle of the hyperbola. Director circle. So it says the locus of the point of intersection of perpendicular tangents drawn to the hyperbola lies on a circle called the director circle of the hyperbola. So its equation is x square plus y square is equals to a square minus b square. Remember, the director circle of the hyperbola, this is not the new thing. So we have already discussed the same concept in the ellipse. There the director circle of the ellipse is x square plus y square is equals to a square plus b square. This is the only difference. Here it is minus b square, here this is plus b square for ellipse. For ellipse, director circle is this. And what is the director circle that we have discussed there? So this is the ellipse and this is the director circle there. And this director circle is formed by the locus of the perpendicular tangents of the ellipse. So this and this are the two tangents. This tangent and this tangent, these two tangents are the tangents for this ellipse, and these two are the perpendicular tangents, and these two are intersecting at this point, and the locus of this point. Likewise, there are so many points are formed. For example, if I take this is the tangent. This is the tangent to this ellipse, and this is the tangent to this ellipse, and these two tangents are perpendicular. So therefore, likewise, there are so many point of intersection of the perpendicular tangents are formed. So all of them if you join, then the circle so obtained is said to be the director circle, and the director circle for the ellipse is x square plus y square equals to a square plus b square. And now here for the hyperbola, so that is, this is the hyperbola, and so let us suppose that this is the tangent for this hyperbola and this is the tangent for this hyperbola. See, both are tangents. This and this are tangents. What is the tangent? The line which touches the hyperbola at one point is said to be the tangent. So this line is a tangent. So this line is a tangent to the hyperbola at this point. So this is the tangent. Likewise, for the same hyperbola, this is another tangent at this point. So these two tangents are perpendicular. So therefore, the locus of these points, if you join, then actually this is what we will be getting. The locus of point of intersection of the tangents drawn to the hyperbola lies on a circle. This circle is said to be director circle. So P x1 y1 I will take proof. Let Px1 y1 be the locus of the perpendicular tangents to the hyperbola. Let y is equals to mx plus or minus square root of a square m square minus b square be the slope form of the tangent to the hyperbola. Since these tangents are passing through this point Px1 y1, since plus or minus means there are two tangents included in this. Since these tangents are passing through Px1 y1, substituting P in this equation 1. In equation 1. So this is equals to y1 equals to mx1 plus or minus square root of a square m square minus b square. Squaring on both sides. Squaring on both sides. Before that, actually this mx1 if I take to this side, y minus mx1 is equals to plus or minus square root of a square m square minus b square. Now squaring on both sides. So this is equals to y1 square plus m square x1 square minus 2 m x1 y1 is equals to plus or minus whole square, so plus only, and square and root gets eliminated, so a square m square minus b square. So from this m square x1 square minus a square m square minus 2m x1 y1 plus y1 square, this minus b square if you transpose to this side, plus b square equals to 0. So this is the quadratic equation. This is the quadratic equation in M. Hence, M has two roots. So here let M1 comma M2 be the roots, and those two roots represents the slopes of the tangents. M1, M2 be the slopes of the tangents which we have taken before. So here m1 plus m2, sum of the roots is minus b by a. So minus b means here the quotient of m. So this is minus 2x1 y1 by the quotient of m square is x1 square minus a square. So this is 2x1 y1 by x1 square minus a square. Now the product of the roots m1 m2 is equals to c by a. So c here is this constant y1 square plus b square by x1 square minus a square. So here this is the hyperbola, and these two are the tangents. So these two tangents, let the slopes of them be m1 and m2. Since the two tangents are perpendicular, since two tangents are perpendicular to each other, that means product of their slopes is equals to minus 1. So m1 m2 is equals to minus 1. m1 m2 is y1 square plus b square by x1 square minus a square, which is equals to minus 1. So this is equals to y1 square plus b square is equals to minus of x1 square minus a square. So this is equals to y1 square plus b square is equals to minus x1 square minus of minus plus a square. This implies x1 square, this on transposing onto this side, it will be plus x1 square plus y1 square is equals to a square. This plus b square if you transpose onto another side, that is minus b square. Therefore, the locus of this point P x1 y1, therefore the locus of P x1 y1 is x square plus y square is equals to a square plus b square. There are so many points formed by the point of intersection of two perpendicular tangents. So all those points if you join, then we will get a circle, and this circle is said to be the director circle. So x square plus y square equals to, this is, so x square plus y square equals to a square minus b square represents the equation of the director circle to the hyperbola. So for the ellipse it is x square plus y square equals to a square plus b square. Now our next topic is the auxiliary circle. The auxiliary circle is nothing but the circle described on the transverse axis of a hyperbola as a diameter is called the auxiliary circle, or it is also defined to be the locus of the feet of the perpendiculars drawn from either of the foci to any tangent concentric with the hyperbola is called the auxiliary circle. So the auxiliary circle is not a new topic that we are learning now. So the same concept we have discussed before in the chapter ellipse as well. So there the auxiliary circle is nothing but, for example, this is the ellipse and this is the major axis there. So the circle described on the major axis of the ellipse. The circle described on the major axis of the ellipse. Now this circle is described on the major axis of the ellipse. A dash is the major axis of the ellipse. And for this circle, this major axis is the diameter of this circle. So therefore this circle is said to be the auxiliary circle for the ellipse. Now the auxiliary circle for the hyperbola is like this. So this is the hyperbola. So this is the transverse axis, and this for this circle the major the transverse axis is the diameter. So this circle is called the auxiliary circle for the hyperbola, and the auxiliary circle for this hyperbola is also x square plus y square equals to a square, just like a ellipse. Our next topic is asymptotes. Asymptotes. The tangents of a hyperbola which touches hyperbola, which touch hyperbola at infinity is called asymptotes. So the equation of the asymptotes are x by a plus or minus y by b equals to 0. This is the hyperbola the tangents of a hyperbola which touch the hyperbola at infinity. So this is the tangent. This is the line which touches the hyperbola at infinity. So we cannot show in the diagram because it touches this line touches the hyperbola at somewhere one point where it is in infinity. So likewise there is another tangent which touches the hyperbola at infinity. Somewhere here it will touch. Then these equation of the tangents are said to be the asymptotes, and the equation of the asymptotes are x by a plus y by b equals to 0 one line, and x by a minus y by b equals to 0 another line, and the equation of the pair of asymptotes are x square by a square minus y square by b square equals to 0. While x by a plus y by b equals to 0 one tangent, and x by a minus y by b equals to 0 another tangent. So these are the individual asymptotes. Now let y is equals to mx plus or minus square root of a square m square minus b square be the slope form of the tangent. Be the slope form of the tangent. So we have already derived the condition of the tangent C for the hyperbola and the line c square equals to a square m square minus b square, and the point of intersection is, the point of contact is minus a square by c comma b square by c, minus a square by c minus b square by c. So the point of contact is minus a square m by c comma minus b square by c. So here minus a square m by c square equals to a square m square minus b square. So c is equals to square root of, so a square m square minus b square, this is minus b square by square root of a square m square minus b square. Since this represents the asymptotes, then the asymptotes touches the hyperbola at infinity. Hence a square m square minus b square equals to 0. So from this a square m square is equals minus b square equals to 0. A square m square is equals to b square. So therefore m square is equals to b square by a square. So substitute here, we'll get y is equals to, in the place of m substitute, so from this m is equals to plus or minus b by a. So substitute plus or minus b by a here in the place of m. So this is plus or minus b by a into x. Then we'll get x by a plus or minus y by b equals to 0. So few points we observed here is the equation of the pair of asymptotes are x by a, x square by a square minus y square by b square equals to 0. Because this is x by a plus y by b equals to 0 one line, x by a minus y by b equals to 0. These are the individual asymptotes line equations. So the combined equation or the joint equation of these asymptotes is x by a plus y by b into x minus a, x by a in minus y by b equals to 0, which is this. Now the equation of asymptotes and hyperbola are differed by a constant. Differed by a constant because What is the equation of the hyperbola? X square by a square minus y square by b square equals to 1. X square by a square minus y square by b square equals to 1. This is the hyperbola. And the asymptotes is x square by a square minus y square by b square is equals to 0. So both are same, differed by a constant here. That's it. And the third one, the asymptotes are passing through the center of the hyperbola. These asymptotes are passing through the center of this hyperbola. See, origin 0, 0. And the asymptotes are equally inclined. Equally inclined. So that means this line and this line are making equal angles with the quadrant axis. So this line makes an angle of 45 degrees and this line makes an angle of minus 45 degrees or 135 degrees with the quadrant axis. So one is any line which is parallel to asymptotes. Any line which is parallel to asymptotes cuts the hyperbola at one point. That means this is the asymptote, and let us suppose that this line which is the parallel to this asymptotes cuts the hyperbola at the unique point. So any parabola, for any line if you take, this is also a line which is parallel to this asymptotes. Asymptotes is the straight line. So this line cuts the hyperbola at one point. Now, so if the hyperbola equation of the hyperbola is x square by a square minus y square by b square minus 1 equals to 0, and this is the asymptotes, and h dash is the conjugate hyperbola x square by a square minus y square by b square equals to minus 1. So that means minus y square by b square plus 1 equals to 0. Now h plus h dash is equals to 2a. So 2 times the asymptotes. So x square by a square minus y square by b square minus 1, x square by a square minus y square by b square plus 1. So these two gets cancelled. So x square by a square plus x square by a square, 2x square by a square minus y square by b square minus y square by b square, 2y square by b square. So 2 if you take common, x square minus a square, x square by a square minus y square by b square, we will get there. So these are the explanation for the asymptotes. Let us consider this example. Find the asymptotes of a hyperbola. Let us consider this example. Find the asymptotes of a hyperbola 4x square minus 9y square equals to 36. So, given equation of the hyperbola is 4x square minus 9y square equals to 36. This, if you try to put it in an order, 4x square minus 9y square by 36 equals to 1. So x square by 9 minus y square by 4 equals to 1. This is the hyperbola given. So the equation of the pair of asymptotes are x square by 9 minus y square by 4 equals to 0. So this implies x by 3 plus y by 4, y by 2 into x x by 3 minus y by 2 equals to 0. Therefore, the equation of the asymptotes are x by 3 plus y by 2 equals to 0, that is 2x plus 3y by 3 to the 6 is equals to 0 and x by 3 minus y by 2 equals to 0. From this 2x minus 3y by 2 3 the 6, if you transpose on to another side, is equals to 0. So these two are the equation of the asymptotes. The combined equation of the asymptotes, the pair of asymptotes are x square by 9 minus y square by 4 equals to 0. Now the next one is the angle between the asymptotes to the hyperbola is 2 tan inverse b by a or 2 secant inverse e. The angle between the asymptotes to the hyperbola x square by a square minus y square by b square is equals to 1 is 2 tan inverse b by a or 2 secant inverse e. Let theta be the angle between the asymptotes x by a plus or minus y by b equals to 0. Other words, y is equals to plus or minus b by a into x. Let m1 comma m2 be the slopes of the tangents. m1 is equals to b by a and m2 is equals to minus b by a. So if theta is the angle, then theta tan theta is equals to m1 minus m2 by 1 plus m1 m2. So this is equals to m1 is equals to b by a minus of minus plus b by a by 1 plus m1 m2, 1 plus b by a into minus b by a. So minus b square by a square. 2 tan alpha by 1 minus tan square alpha, where b by a is equals to tan alpha. From this, alpha is equals to tan inverse b by a. So this is equals to tan theta is equals to 2 tan alpha by 1 minus tan square alpha is tan 2 alpha. So theta is equals to 2 alpha. So 2 into alpha is tan inverse b by a. So 2 into tan alpha is b by a. Then we have secant square alpha minus tan square alpha equals to 1. So secant square alpha is equals to 1 plus tan square alpha. From this, secant square alpha equals to 1 plus tan square alpha. So this is 1 plus b square by a square. So from this, a square plus b square by a square, secant square alpha is. So from this, secant alpha is equals to square root of a square plus b square by a square. So from this, alpha equals to secant inverse square root of a square plus b square by a square. So 2 into, this is tan inverse b by a. So alpha is equals to tan inverse b by a. The same alpha is this secant inverse square root of a square plus b square by a square. So this is, so for the hyperbola x square by a square minus y square by b square equals to 1, we have b square is equals to, we have the eccentricity E is equals to square root of a square plus b square by a square. So this a square plus b square by a square is nothing but E. So 2 secant inverse E. So the angle between the asymptotes is either 2 tan inverse b by a or 2 secant inverse E.